Autophagy, the cellular process of self-renewal and repair, is tightly governed by nutrient-sensing pathways, especially mTOR, mechanistic target of rapamycin, and AMPK, AMP-activated protein kinase. These two systems act as metabolic switches, detecting cellular energy status and responding accordingly to either suppress or activate autophagy. Under healthy conditions, they help maintain cellular balance by adjusting metabolism to match nutrient availability. But in obesity, this finely tuned regulation often becomes disrupted, impairing the cell's ability to initiate autophagy when it is most needed, and thereby contributing to metabolic dysfunction, inflammation, and accelerated tissue damage. mTOR is perhaps the most prominent autophagy suppressor. When nutrients, particularly amino acids and glucose, are abundant, mTOR remains active, signaling the cell to grow, synthesize, and store rather than recycle. This is appropriate in short bursts, such as after meals, but chronic overnutrition, as seen in obesity, keeps mTOR persistently activated. This chronic mTOR stimulation essentially blocks autophagy over time, preventing the removal of damaged organelles, oxidized proteins, and excess lipid droplets. In tissues like the liver, pancreas, and adipose tissue, this suppression of autophagy can lead to a buildup of cellular debris, increased oxidative stress, and an elevated risk of insulin resistance and fatty liver disease. On the other side of the spectrum, AMPK serves as the cell's energy sensor. When energy is low, during fasting, exercise, or caloric restriction, AMPK is activated, which in turn inhibits mTOR and triggers autophagy. It's a brilliant system. When energy is scarce, the cell cleans itself out to recycle components for survival. In obesity, however, AMPK signaling is often blunted due to constant energy surplus and insulin resistance. This results in a double hit. Not only is mTOR chronically activated, but AMPK is unable to counteract it. This dual impairment blocks the natural cycles of repair and regeneration, contributing to the persistence of fat accumulation and metabolic disease. Despite these challenges, the story is far from hopeless. One of the most promising aspects of this pathway-based understanding is the ability to reverse dysfunction by restoring balance to mTOR and AMPK activity. For example, intermittent fasting and exercise are two well-studied strategies that reduce mTOR signaling and enhance AMPK activation, thereby reactivating autophagy. Even short periods of caloric restriction or time-restricted eating can shift these pathways enough to allow the cell to enter repair mode, clearing out accumulated waste and restoring organelle health. This is particularly beneficial in liver and adipose tissue, where autophagic suppression has the most damaging consequences in obesity. Moreover, certain nutrients and natural compounds have shown potential to modulate these pathways. Polyphenol like resveratrol, curcumin, and EGCG from green tea can activate AMPK and inhibit mTOR, mimicking some effects of fasting at the molecular level. Metformin, a drug commonly used for type 2 diabetes, also activates AMPK and is being explored for its ability to promote autophagy in multiple tissues. These interventions may help break the cycle of energy excess and autophagy suppression that traps cells in a state of metabolic dysfunction. Importantly, the balance between mTOR and AMPK must be carefully regulated. Too much inhibition of mTOR, for example, can impair muscle growth, immune function, and wound healing. Autophagy itself, when excessively activated or unregulated, can become damaging, potentially leading to cell death rather than survival. Thus, the goal is not to eliminate mTOR signaling or constantly stimulate AMPK, but rather to restore a rhythmic, responsive interplay, one that allows autophagy to turn on when needed and turn off appropriately. In essence, mTOR and AMPK are not just abstract molecular players, they are gateways to health or disease. In obesity, their dysregulation hinders the body's natural renewal processes, allowing dysfunction to build unchecked. But through lifestyle strategies, targeted nutrients, and potentially future therapeutics, we have real opportunities to reactivate these systems, restore autophagy, and rebuild metabolic resilience. Understanding and addressing this molecular miscommunication may be one of the most important keys to reversing obesity's long-term consequences.